Good morning all. Just doing a video here looking at the start of the software journey for this software defined radio. So in this video I just want to just briefly cover up on the changes we've made to the hardware, and then we will start to look at the software design tool. That's very useful, the online tool for understanding better how to use the library that is being put out by PRGSA, the creator of the Teensy, and then we'll look at the code, the changes to the current code to allow the audio codec to start working. So initially what we're going to do is we're just going to feed, as I mentioned in the last video, audio straight into the audio shield, and then we're going to take it straight through with no DSP, no manipulation, straight out, in this case through this little amplifier here. So at the moment it's hooked up, 80 meters. It's the morning here, there's nothing going on that I can hear, but it's more just looking at what's been changed. Oh, sorry. So we've now removed that big black wire we talked about last one, and it's got some little audio cables here taking the audio out from both the I and the Q channel and feeding that down into the line in on the audio shield. On the other side, I haven't bothered to use a 3.5mm audio connector here, and I've just sort of tapped directly into the pins there. Just tapped into, I think it's left, because the output of this is going to be not binaural, but it's going to be, it's a mono output. So we've got stereo going in, which is our I and our Q. We'll do the DSP, we'll eliminate that unwanted sideband, and then we'll just output one channel of audio, which has now been fed through into that simple little audio amplifier that we're using before, that was sitting over here. So like I say, there's really no activity. If there was, it would be exactly the same as we had the other night when we were listening to the national broadcast. Really no difference. It's exactly if it was just wide straight through, no difference at all. So I won't ponder here. Let's go and have a look at two things. First we'll have a look at like I say, the online design tool that's used, and then we'll look at the changes in the code to allow exactly this to happen, the audio to come in and go straight through the output. So let's just break there, and we'll bring up the design tool. Right, this is the audio system design tool that PJRC have created to help create the code for dumping into or importing into your programs for the Teensy. I only really use this program for understanding what the various audio functions or objects or whatever you want to call them, how they work. But for those initially setting out, it's quite a good way of sort of understanding how the code works. So for example, on the left hand side are all the various functions or objects that this audio system can do. And if you hover your mouse over them, you get a picture of what they are to get a bit of an understanding what they are and what they do. Now, the codec we have on this board is the SGTL 5000. So I'm going to grab that and I'm going to plonk that with my mouse and just drop it onto, we'll call this the work surface or the working area. We need that because when we create or when we export, that'll create the or initialize that particular function in the code. Yeah, full stop. Right, so for this first initial program, what we want to do is just take whatever's coming in on the line in and feed it directly to the line out. So under the input section, we want to use this one here, the I2S. And if I hover over it, you can see the picture, and you'll recognize that as being the audio shield with the two line ins. So I'm going to grab that and I'm going to just drop it there. and we also need to have a way of outputting it. So in the output section, again, under the I2S, if I hover over that, you can see there the options for feeding audio out is through, in this particular case, the line out pins or through the headphone. So I'm going to grab that also, and I'm going to drop it somewhere around there. Now, the way the audio shield works in the code is you use things called patch cords. So patch cords are akin to sort of audio panels, in the old days with the cords with the 5mm plugs, or an old telephone exchange where the staff there would connect two telephone lines together with a patch cord. So it's the same sort of thinking and methodology used here. So in order to join two objects together, you can see that each of these objects has a little sort of a bubble at each end, and they represent the inputs and outputs. So for this particular one here, if I hover and then click my mouse, keeping the button down, I can now draw a line and join it to somewhere else. So I'm actually going to join it to here. And I know that for this object, if I click on it, down the bottom here, under the audio connections, you can see that there's two ports, a 0 and a 1. So 0 is for left channel and right is for 1. Now that'll become more apparent when we look at the code. So at the moment, I've just connected the left channel in to the left channel out, and I'm going to do the same for the right channel. Click, hold the mouse down, release. Now, for whatever reason, if you make a mistake, you can just highlight that and delete, and you can make it disappear. So again, I'm going to put it back again though. So that there has now created visually a straight feed through, inputting audio going straight through the output. Now if I was to click this export here, it will generate for me code, and it's ready to copy and paste into your program. Like I say, I don't particularly do that, but it does give you an idea of how things are set up. And when we look at the actual code, you'll see how this has been done. How you initialize here the audio control codec itself, the SGTL 5000, and you'll see there those patch cords. So patch cord number 1 is going from, if I just pull this down, what they've called here I2S1, so I2S1 0, so that's the left channel, going to I2S2 up here, I2S2 channel 0. Now I don't find these initial names very useful, so you'll see in my code how it's very, very easy to assign these objects your own name, which I find very easy for just looking at the code, what's going where. But anyway, what I typically use this program for, or this website, is to understand how various functions work. And two that we are going to be using is, one is the mixer, so I'm going to drag that out there, and the other one is under effects called multiply. Now this is the names that are given to these objects. Now in a radio context, a multiplier, if I click on it, you can see on the right hand side here a whole lot of information about how it works and what it is. And as you can see, this here multiplies two signals together. So we would call that in radio terms a mixer. So it's a little bit confusing because right above it is something called a mixer. Now if I look at that particular object, so I highlight it, you can see that what this one here does is actually just mix or combine, in this case, up to 4 channels. So there's no multiplication going on. This is purely additive. So it's a little bit confusing if you're using this particular audio library in a radio context, because the default names are not what you'd expect them to be. But again, the beauty of this library is you can very easily change these names in code to be something more meaningful, and we'll see that as we move forward. But just to just not to be confused, that mixer is not actually a radio mixer. It's I guess a summer. It's summing things together. And I will point out now, and I'll go through it again later on in future versions of the software, we can set various gains. So for example, here, I'll just mention here, we can set individual gains for channels. So if I was to set, say, channel, this one here, channel 0, gain to 0, I've effectively turned that channel off. If I assign a gain of 1, I've got maximum input. And if I say gave it -1, I've actually inverted the input. And that'll become very useful later on when we start using our phasing technique for eliminating the unwanted sideband. That'll become very important indeed. And as we saw there with the multiply, we're not going to use that initially, but at some point we may look at playing around with having a 10 kilohertz IF coming in, and then we will, through this particular function here, multiply that by a digital local oscillator, or BFO in this particular case, and we will then bring that 10 kilohertz down to 0 hertz. But initially we won't do that, but just letting you know that if you want to have a look at that early, it's the multiplier we'll be using. Again, if you don't want things, you can highlight them, delete, and they disappear. So that's all I'm going to say at this point in time for the audio design shield. But that just gives you an idea of what it is and how I use it. And when we compare that with the code, it'll make a whole lot more sense what these lines here mean and how you do that in the code. So I'll leave that there, and we'll come back and have a look at the code like I say. So we've now just finished using the online audio shield to get a bit of an understanding of the various audio objects. So now we can sort of see how that's been used in the code. So this code here is the same code that we used, or we showed the other day when we were just looking at initially just setting up that quadrature local oscillator. And all I've done now is just added in a few more features which we'll look at right now to enable the audio shield and to enable the audio in to go straight through to the audio out. So I think probably the best way of doing this is just to start at the top, and it shouldn't take too long at all. So in the includes, we've got one extra include here. We've just included the Teensy's audio library, so audio.h. So that's the first thing that we need to have. No changes to those sections there. And under creating and setting up the objects, we've now got here that you'll recognize that audio control SGTL 5000, and we're just going to call it audio shield, which is quite a common term and makes perfect sense to me. So that's the object, and it's going to be called audio shield, which makes sense, like I say. So in terms of that audio shield itself, we are going to, and you'll recall that the default names for that input was I2S1 and I2S2, which is a little bit confusing. So here you can see how we can straight away assign some nice obvious names. So for the input, we basically create this object here, input I2S, and we're going to call it audio input. And for the output one, we're going to call it audio output. So that makes it nice and simple. So when we actually start setting up the patch chords, we actually get some pretty useful and obvious names, which makes it nice and easy to understand and to debug your code later on if things don't work. So here, like I say, that input one, audio input, the output one we've called audio output, and now we set up the audio connections. So this is those patch panels, those pieces of wires with a couple of plugs in each end that we can now, in software, connect those two objects together. Now, they had to have unique numbers, so this one's called patch cord 5 and the second one I've called patch cord 10. I could have made that patch cord 1 and patch cord 2, but I like to have at least say 5, it could be 4, but a gap between the two, that if I'm going to increase future functionality, I like to, and it logically sits between these two in the big scheme, then I've got room to insert it. So I can basically here create a new line, do another audio connection, and I can call this one here, for example, it could have been patch panel 7 or 6, 7, 8, 9. I've got quite a bit of room there. So that's why I tend to go up in 5s. Let me just bring that back up again. I go up in 5s. So the first one here, is patch chord 5, and it's now going using our nice useful names, audio input, channel 0, which is our left channel, going straight through to our audio output, channel 0, and the second patch chord 10, is going from input 1, which is our right channel, to audio output, right channel. So that's all we got to do to basically allow that to happen. Now in the setup area of the program, we also have to do a few things to make that audio shield work. So we'll just nip down, and this is the new code that's been added in. It's good practice if you are manipulating the that codec, is to turn off the interrupts. So the starters, and you'll see this used later on before we do any manipulations, and then after we turn them back on again. So audio, no interrupts, and then at the very end, audio interrupts. So let's turn the interrupts off. The audio, we need to assign some memory to allow that audio shield to work correctly. The default is 12 often. 16 seems to work as well, so anywhere between those for a starter for 10. Now the audio shield, now remember that's what we've decided to call that codec, so that SGTL 5000, the big chip on that board, we've called audio shield, so that's the object. So now we can manipulate various functions of that. So audio shield dot enable, so we're now enabling it. Audio shield dot input, we're going to call the audio input line in. So we're basically saying that for that I2C, this one here, the input for that one is going to be the line in. So that's what that line there means. The audio shield volume can be between 0 and 1. I've just got it defaulting to 7. There's nothing stopping you from having a potentiometer being fed into one of the analog pins, and then converting that into a number between 0 and 1 and feeding it in here, and then you can actually on the fly then adjust the volume coming out of the audio shield. But just for a default, I'm just using 0.7. And we're going to unmute line out. So we just nip back up again. That's this one here. So for that particular function of the audio library, the audio output, we're going to unmute line out. Right, which basically means then the line out and the headphones are enabled. And that's it. That's the only thing that needs to be done. There's no changes to the loops. There's no changes to the interrupts. Everything else is exactly the same. And that's all to do at the moment with reading the rotary encoder and setting up the SI5351. So again, just a matter of getting that audio library in, creating the master object for the codec, assigning some useful names to the functions that sit within that library, setting up our patch chords, and we'll have many more patch chords to come as we continue developing this radio to use various digital filters and the like. But at the moment this is purely just testing out the code to make sure that whatever comes in can go straight out. And then under that setup area, just setting up some of the initial parameters for the audio shield. It is pretty straightforward, and once you get done this a couple of times, you'll get the hang of it, of what needs to be done. And again, all of this all of these settings here. It's just a matter of going back to that audio design tool online, clicking on objects, then on the right hand side you can see how various objects work and how you would manipulate them in here in the actual main code itself. So there you go. I'll put this up on the blog, and next steps will be to start looking at how we're going to create this phasing receiver and the various filters, and we'll use the Iowa Hills website or the Iowa Hills free tools for creating those digital filters. Once again, and I've said this before, I apologize for the low volume. I've plugged in now 3 separate different kinds of headphones into this and microphones, and I really cannot make the audio any louder. I'm on max gain on the microphone, the internal microphone, and I really don't know what to do. I haven't tried Bluetooth, I must admit. I've tried filming directly the screen, but unfortunately we get some strange, I don't know if it's aliasing or some wavy lines coming across, which is a little bit annoying. I tried putting the image onto a separate LCD monitor, but again there's some slow moving bars moving through the image. Perhaps I'll give that a go, and if it's really annoying, let me know. But then I can at least use the normal camera, which has the much better audio. So again, apologise for that. It's a little bit out of my control, unfortunately, at this stage. Anyway, 73s, and we'll continue developing, and we'll see you next time. Cheers all.